Hello and welcome to a lesson on sine and cosine rules. This lesson is equally applicable to A-level AS modules and to GCSE higher tier. In the lesson, I'll explain what the sine rule and the cosine rule are, and we'll look at how they can be used to find sides and angles in any triangle, not just right-angled triangles. We've seen in basic trigonometry that we can use sine, tan and cosine to find angles and sides in right-angled triangles. But what happens when the triangles are not right-angled? It's then that we need to use sine rule and cosine rule to solve triangles, that is, to find missing angles and missing sides that we don't yet know. I'm going to begin with sine rule. And here I have a triangle labelled ABC. We use capital letters for the corners and we mark the opposite side to an angle with the corresponding lowercase letter. So side little a is opposite angle A, side little b is opposite angle B, and side little c is opposite angle C. And if that's the case, this is the sine rule. A over sine A is equal to B over sine B is equal to C over sine C. And it's valid for all triangles. Now, it's important to recognize the patterns, because when you want to find sides or angles in triangles, they're not all going to be called ABC. In fact, they might not be called anything at all. So the patterns are that one side divided by the sine of the angle opposite is equal to another side divided by the sine of the angle opposite. And you only need two pairs in which to calculate a missing side or a missing angle. But we can only use sine rule if you know a complete pair. You must know a side and the opposite angle. Let's have a look at an example. This is the first of 4 examples on sine rule, 2 of which we'll be using to find a missing side and 2 of which we'll be using to find a missing angle. Now, why can I use sine rule here? Because I know an opposite pair. I know this angle is 70 degrees and the opposite side is 13. That's essential before we can use sine rule. I want to find x, and I can use sine rule because I know the opposite angle to x. So I can write x over sine 60 is equal to 13 over sine 70. And let's just have a close look at that. It's x over the sine of the opposite angle is equal to 13 over the sine of the opposite angle. So in this equation here now, there's only one unknown. And to get x on its own, I simply need to multiply by sine 60 degrees. So the right-hand side becomes 13 divided by sine 70 degrees multiplied by sine 60 degrees. And now I need my calculator. Let's make sure it's in degree mode. It is. And I've got 13 divided by the sine of 70, and in this calculator you type 70 then hit the sine button, multiplied by sine 60. So that's 60, the sine of that equals 11.98. Let's give the answer to 2 decimal places. 11.98. 11.98 what? Well, this side he was measured in centimetres, so the answer will also be in centimetres. So we've now found the missing side. Let's move on and look at a second example. This time I've marked on all 3 angles. You'll see they add up to 180, 110 plus 40 is 150, plus 30 is 180. The question is, which angles do we use to find x? Well, we need to know a complete opposite pair. So if I'm working with 21 meters, I'll also be working with 30-degree angle. 21 over sine 30 is equal to x over sine 110. So let's write that down. X over the sine of 110 degrees is equal to 21 over sine 30. Now to get x on its own, I simply multiply through by sine 110 degrees. So we get 21 over sine 30 multiplied by sine 110. So x is equal to 21 divided by the sine of 30 multiplied by the sine of 110. And that gives me 39.47. 39.47, and this time the units are in meters. And that completes example 2. In example 3, we'll move on to find an angle, calling the angle theta. But again, I can use sine rule because I've got this complete pair. I know this side and the opposite angle. So I can simply write down that 18 over sine 77 is equal to 15 over sine theta. And what we do now is what mathematicians call cross-multiplying. In effect, we're just multiplying the equation through by both denominators. The left-hand side becomes 18 multiplied by sine theta equals the right-hand side 15 sine 77 degrees. You see why it's called cross-multiplying? It's because when I've got two fractions the same, I'm saying that that one multiplied by that one is the same as that one multiplied by that one, cross-multiplying. But it's just basically multiplying the equation through by both denominators. If I multiply the equation through by sine 77, it cancels out on this side and appears up here. And if I multiply the equation through by sine theta, it cancels out on this side but appears up there. Right, so now let's get sine theta on its own. Sine theta is equal to 15 sine 77 degrees divided by 18. So theta is sine to the minus 1 of this expression here. 15 sine 77 divided by 18. Remember, sine to the minus 1 function is the function that tells you which angle this sine is. And you can either work this out first and then do the sine to the minus 1, or you can do it all in one operation on your calculator. So theta is equal to sine to the minus 1. I will do what's in here first. So let's find 15 sine 77 divided by 18. 15 multiplied by sine 77. On most calculators you just type in sine 77, but on this one you have to type in 77 and then hit the sine button. Equals, so I've worked out the top, divide by 18. I've now got this whole expression is 0.8119, and I want sine to the minus 1 of that. And on this calculator I press the up arrow to get the sine to the minus 1 function, and the answer is, to one decimal place for angles, 54.3 degrees. 54.3 degrees. Moving on now to example 4. I've made this one more complicated. We're going to have a look at something called the ambiguous case of the sine rule. It turns out that sometimes there can be more than one answer when you're trying to find an angle. In this triangle, there's a 25-degree angle. The opposite side is 3 centimeters. There's an angle theta, and the opposite side is 5 centimeters. So everything's ready to use the sine rule. But if you look where I've marked in the two dotted bits, that 3 centimeter side could also go down there. See how there's an isosceles triangle there with two 3 centimeter sides. And we can't be sure which way it is. If it's there, theta will turn out to be obtuse. But if it goes down there, theta, which I've called theta dash in this case, would be acute. And we can find both angles. So let's use sine rule and see what happens. we get 3 over the sine of the opposite angle, 3 over sine 25 degrees, is equal to 5 over sine theta. So it looks the same as the previous example. Let's cross multiply. 3 times sine theta is equal to 5 sine 25. So sine theta is equal to 5 sine 25 degrees divided by 3. So theta is equal to sine the minus 1 of the expression on the right. 5 sine 25 degrees divided by 3. So theta is equal to, let's get the calculator. First of all, 5 times the sine of 25 equals, divide by 3 equals, now I want the sine the minus 1 of that, and I've got 44.8 degrees. So theta is 44.8 degrees. Now then, what is the other answer? Well, the sine graph, if I do a sketch of the sine graph from 0 to 180, it looks like that. Sine 90 is 1 and it comes back down to 0. So the sine of 44.8 degrees is also equal to the sine of 180 minus 44.8 degrees. So theta can also be 180 minus 44.8 degrees, which would be 135.2 degrees. Now, how do I know whether I can have both those answers? Well, what I can do is check to make sure we haven't exceeded the total angle sum of the triangle. And you can see if I have 135.2 and I add on 25, that will only take me to 160.2. So there'd still be almost 20 degrees left for the other angle. So in this case, both those answers are valid. Often when you do it, you'll find if you look at the obtuse one, when you add it to the angle you already know, you'll be past 180 degrees and it'll be impossible. Right, so that's basically an ambiguous case of the sine rule, where really when you use it to find an angle, you should just check the obtuse angle, 180 minus the one you found, to see if that's possible as well. I'll now move on to introduce cosine rule, and then we'll look at 4 examples, 2 to find a side and 2 to find an angle. Using the same triangle I started with originally, ABC with the opposite sides marked little a, little b and little c, cosine rule is a squared equals b squared plus c squared minus 2bc cos a. It's a bit of an extension of Pythagoras' theorem. If a was 90 degrees, cos 90 is 0, you'd actually have Pythagoras' theorem, a squared equals b squared plus c squared. This formula is given on the GCSE formula sheet, and it's also given on the A-level formula sheets. However, the way it's set up there is to find a side. We'll find a squared and take the square root to find the side. There's also an angle form to find an angle. And the strange thing is, the angle form is given on the A-level formula sheet, but it's not given on the GCSE sheet, so you need to be able to derive it. So let's have a rearrangement. I want to find cos A. What I'll do is I'll bring this term here, minus 2bc cos A, which means 2 times b times c times cos A. I'll bring that to the left-hand side and it'll become positive. I'll take the a squared to the right-hand side and it will become negative. So that will give me 2bc cos A is equal to b squared plus c squared minus a squared. And then to get cos A on its own, I simply need to divide the right-hand side, all of the right-hand side, by 2bc. So it becomes b squared plus c squared minus a squared, all divided by 2bc. So let me just summarize that. There it is. To find a side, we use a squared equals b squared plus c squared minus 2bc cos a. And to find an angle, we use cos a is b squared plus c squared minus a squared divided by 2bc. Now, as before, you've got to get away from the letters and recognize the patterns. So let's have a look at the pattern here to find a squared. What do we need to know? Well, we need to know the other two sides, and we need to know the angle opposite a. So we use cosine rule to find a side when we know two other sides and the angle in between them. So we don't know an opposite pair. In this case, we can't use sine rule. If we try to find an angle, let's have a look at the pattern here. If I'm trying to find the cosine of angle A, it's this one squared plus that one squared minus the opposite one squared. So all the squares are on the top of this fraction, but the negative one is the one opposite the angle you're trying to find. Then we divide by 2 times one side times another side. Well, which sides are they? They're the two sides that are not opposite the angle, and that's what you've got to recognize and look out for. We'll now look at 4 examples using cosine rule, 2 to find a side and 2 to find an angle. Example 5. To find a side labelled x. So in this triangle, I've got a 15 centimetre side and 11 centimetre side, and I know the angle in between them. That's what I need to be able to find x, the side opposite the angle that we know. So I can write down that x squared is equal to the sum of the squares of the other two sides, 11 squared plus 15 squared, minus 2 times 11 times 15 times the cosine of 66 degrees. And that can be entered straight into the calculator to find x squared. So 11 squared plus 15 squared minus 2 times 11 times 15 times the cos of 66. And that comes to 211.7769. 211.7769. You don't necessarily need to write that down. You could go straight to the square root. So let's have the square root now to find x. And it's 14.55 to 2 decimal places. 14.55. And the units will be in the same units as the other two sides, centimetres. So there's our first example, finding a side using cosine rule. Moving on to example 6, again to find a side x. This time the angle is obtuse. It won't make any difference. The cosine of an obtuse angle is actually negative, and it will turn this term here positive, with the negative at the front multiplied by another negative. But we won't see any of that because the calculator will take care of it automatically. We will just type in what we see. So it's a case of x squared is equal to 29 squared plus 23 squared minus 2 times 29 times 23 times the cosine of 114 degrees. And we can put that straight into the calculator. (29 squared plus 23 squared minus 2 times 29 times 23 times the cosine of 114 times the cosine of 114 is equal to 1912.6. 1912.6. That has no meaning though, it's the square root of that I want to find the value of x. So let's find the square root and we get 43.73. 43.73 and the units will be in meters. And that concludes our second example of finding a side using cosine rule. In our last two examples, we'll be using cosine rule to find an angle. Now this is an easy one to remember. To use cosine rule to find an angle, you need to know all the three sides. And you certainly can't use sine rule if you don't know any angles. Right, cos A is b squared plus c squared minus a squared over 2bc. How can we apply that when we haven't got any a, b's and c's on the triangle? Well, it's the three squares on the top of the fraction. Two of them are positive, one's negative. The one that's negative is the one that's opposite the angle. So I can say that cos theta is equal to 6 squared plus 7 squared minus 8 squared. 6 squared plus 7 squared minus 8 squared divided by 2bc. Now the one that's missing, the a, is the one that's opposite the angle you're trying to find. So this should be 2 times 6 times 7. So cos theta is equal to, let's work that out on a calculator. And we've got 6 squared plus 7 squared minus 8 squared equals 21 divided by, and I'll open brackets, 2 multiplied by 6 multiplied by 7, close the bracket, equals 0.25. So cos theta is 0.25, which means that theta is cos the minus 1 of 0.25. So theta is equal to cos the minus 1 of that. Cos the minus 1 of that is 75.5 degrees. 75.5 degrees. And I'm sure you'll be glad to know there's no ambiguous case of the cosine rule. It always gives you the answer that you need. Let's move on now to look at our last example. And the way I've drawn this, it looks like maybe we're going to get an obtuse angle for theta, but again the calculator will take care of that. So cos theta is equal to, now it's this one squared plus that one squared minus the opposite one squared. So it's 7 squared plus 9 squared minus 14 squared divided by 2 times 7 times 9. So the one that's missing is the one that was negative on the top. So cos theta is equal to 7 squared plus 9 squared minus 14 squared equals, and you can see I've got a negative number. Now I'm going to divide that by, open bracket, 2 multiplied by 7 multiplied by 9, close bracket. So that's minus 0.5238. Minus 0.5238. So theta is cos to the minus 1 of this negative number here, 0.5238. So I just need cos to the minus 1 of that, and there, sure enough, it gives me the obtuse angle, because the cosines of obtuse angles are negative. 121.6 degrees. Theta is equal to 121.6 degrees. And that concludes this lesson on sine and cosine rules. You'll now find an exercise, two exercises actually, 4 questions where you're told what to use, sine rule or cosine rule, then 6 questions in the second exercise where you have to decide whether to use sine rule or cosine rule. So how do you decide? Well, to use sine rule, you need to use an opposite pair. You've got to know an angle and a side that's opposite that angle. For cosine rule, you need to know two sides and the angle in between those two sides to find a side, or you need to know all three sides to find an angle.